So one of the most powerful predictive tools that we can use to determine the structure of molecular compounds and also say something about the kind of bonding that we see with ionic compounds. One of the most powerful tools that we can use is this concept of the Lewis dot structure. Lewis dot structures involve valence electrons. Those electrons that are in the outermost shell of the atom, of the nucleus. We're going to talk about how to do Lewis dot structures for molecules, but let's first talk about Lewis dot structures for individual atoms. Since Lewis structures only involve valence electrons, to determine the number of valence electrons for a main group element, we just use the group number to determine the number of valence electrons. So for example, lithium and hydrogen, those are both in group 1. Each of those have 1 valence electron. Carbon's in group 4, it has 4 valence electrons. So its Lewis dot structure has 4 electrons. And so when doing Lewis dot structures for individual atoms, when we place those electrons around the atom, we do them singly first around the 4 sides of the atom, and then and only then do we double up. So, for example, with the carbon is in group 4. It has 4 valence electrons. Those 4 valence electrons get paired singly first. We're out of valence electrons, so that is for carbon. If we were to do nitrogen, nitrogen has 5 valence electrons. So we would do singly first, and then and only then pair up as needed. It doesn't matter if if those 2 electrons are on one side of the nitrogen or on the other side, just as long as they are singly paired first and doubly paired second. So that's how to draw Lewis dot structures for individual atoms. We can use those Lewis dot structures for individual atoms to say something about the kind of bonding that we see in ionic compounds. For example, we know from previous chapters that the chemical formula for potassium chloride is KCl. For every 1 potassium, there's 1 chloride. Because you learned that group 1 elements like to be +1 when in an ionic compound. Group 7 elements like to be -1 when in an ionic compound. Well, now we can kind of see why that 1 valence electron from potassium gets donated to the chloride ion. And now I have my positively charged potassium and my negatively charged chlorine. So those Lewis dot structures can help predict or explain why we see the kinds of ionic bonding patterns that we do. So the next question is, well, that's great, but how did I know, aside from me telling you, how did I know that potassium was going to donate that electron to chlorine, instead of the other way around? So how do you know which atom does the transfer? To determine that, we need to introduce this concept called electronegativity. That will be the focus of our next video.